GCP Exam Question Overview. Welcome to the channel. Please consider subscribing. I produce videos daily covering a wide variety of cloud topics with a focus on networking. Also, hit the bell icon to get notified of new videos. Today, we're analyzing a Google Cloud Professional Network Engineer exam question that tests your understanding of hybrid DNS architectures. This type of question is common in the certification exam because DNS integration between cloud and on-premises environments is a fundamental requirement for most enterprise deployments. Let me read the question exactly as it appears in the exam. Let's say as the network engineer on a GCP project, you are tasked with designing and implementing a DNS solution for resources in GCP and the on-premises network. The GCP resources should be able to resolve domain names on the on-premises network and vice versa. Which of these solutions can be used? This question is testing several key concepts that every GCP network engineer must understand. The difference between DNS forwarding and DNS peering, the distinction between private and public zones, and most importantly, how to enable bidirectional DNS resolution in a hybrid environment. The four answer choices represent different combinations of DNS integration methods and zone types. Each choice seems plausible at first glance, which is typical for Google certification exams. However, only one option provides the complete solution for bidirectional resolution between GCP and on-premises networks while maintaining security best practices. What makes this question particularly challenging is that it requires you to understand not just what each technology does, but also their limitations. For example, knowing that DNS peering sounds like it could work with on-premises networks, but understanding why it actually can't, is crucial for selecting the correct answer. DNS forwarding versus DNS peering. Before we analyze our options, let's understand the two key DNS integration methods in Google Cloud: DNS forwarding and DNS peering. These are fundamentally different approaches to connecting DNS systems, and understanding their differences is crucial for choosing the right solution. DNS forwarding is like having a smart postal service. When Cloud DNS receives a query it can't answer, it forwards that query to specified DNS servers, in our case, the on-premises DNS servers. It's an I don't know the answer, but I know who might approach. The forwarding is conditional based on domain names, so you can say forward all queries for star.company.com to these on-premises servers. DNS peering, on the other hand, is more like merging address books. It creates a direct relationship between your VPC network and another network's DNS. When you set up DNS peering, queries for specific zones are automatically sent to the peered network's DNS servers. It's particularly useful when you have multiple VPCs that need to share DNS information. Now, here's the critical distinction for our hybrid scenario. DNS forwarding works with any DNS server accessible via an IP address, which is perfect for on-premises integration. DNS peering is designed for VPC to VPC scenarios within Google Cloud. Since we're dealing with on-premises infrastructure, DNS forwarding is our primary tool. The inbound DNS forwarding policy is what makes the magic happen for the reverse direction. Without it, your on-premises servers can't query Cloud DNS. This policy essentially opens a door allowing external DNS servers to query your private zones in Cloud DNS. It's like giving your on-premises DNS servers a special pass to look up GCP resources. Looking at our comparison table, you can see that DNS forwarding with inbound policies gives us exactly what we need: bidirectional resolution, support for on-premises integration, and the ability to handle private zones. This is why it's the cornerstone of most hybrid DNS architectures. Let's analyze each option to understand why DNS forwarding for private zones and setting up a DNS server policy to allow inbound DNS forwarding is the correct solution for our hybrid DNS challenge. Starting with option 1. DNS forwarding for private zones with inbound DNS forwarding. This is our winner because it provides exactly what we need for bidirectional DNS resolution. When you configure DNS forwarding for private zones, you're telling Cloud DNS to forward queries for specific domains to your on-premises DNS servers. The inbound DNS policy is the crucial second half. It creates DNS endpoints in your VPC that on-premises servers can query to resolve GCP private zone records. Option 2. DNS peering for private zones with inbound DNS forwarding. This won't work for our scenario because DNS peering is designed for VPC to VPC communication within Google Cloud. You can't peer with on-premises DNS servers. Even with inbound DNS forwarding enabled, the peering mechanism itself isn't compatible with external networks. This option would be great if we were connecting two GCP projects, but not for hybrid scenarios. Option 3. DNS forwarding for public zones. This is a non-starter for internal resources. Public zones are meant for internet-facing resources and are queryable by anyone on the internet. You definitely don't want your internal database servers or application endpoints in public DNS zones. This would be a serious security risk and doesn't align with private networking best practices. Option 4. DNS peering for public zones. This combines two incompatible concepts. First, you can't peer with on-premises networks as we discussed. Second, public zones don't need peering because they're already publicly accessible. This option doesn't make architectural sense for any scenario, let alone our hybrid private network requirement. The key insight is that our solution needs three components: private zones for security, forwarding for on-premises integration, and inbound policies for bidirectional resolution. Only option 1 provides all three, making it the clear and only viable choice for this hybrid DNS architecture. Implementation details. Now let's dive into the actual implementation of our DNS forwarding solution. I'll walk you through each step with the specific G-Cloud commands you'll need to execute. This implementation creates a robust, bidirectional DNS resolution system between GCP and your on-premises network. First, we create a private DNS zone for our GCP resources. To do this, run the command G-Cloud DNS managed zones create GCP private. You'll set the DNS name to gcp.company.internal. Provide a description like private zone for GCP resources. Specify the networks as my VPC, and set the visibility to private. This creates a private zone that's only accessible within your VPC. The visibility equals private flag is crucial here, as it ensures this zone isn't exposed to the internet. Next, we set up DNS forwarding to your on-premises DNS servers. The command for this is G-Cloud DNS managed zones create on-prem forward. Here, you'll set the DNS name to company.com, add a description like forward queries to on-premises, specify the networks as my VPC, and set the visibility to private. You'll also provide the forwarding config, which are the IP addresses of your on-premises DNS servers. For example, 10.0.1.10 and 10.0.1.11. This creates the forwarding zone. All queries for company.com and its subdomains will now be forwarded to these servers. The crucial third step is creating the inbound DNS policy. This is what allows on-premises servers to query our cloud DNS. Use the command G-Cloud DNS policies create inbound policy. You'll need to include the enable inbound forwarding flag, specify the networks as my VPC, and add a description such as allow inbound DNS queries. When you run this, Google Cloud automatically creates DNS forwarder IP addresses in your VPC that on-premises servers can use as DNS servers. After creating the inbound policy, you need to list the inbound forwarder IP addresses. Run the command G-Cloud compute addresses list, and use the filter where purpose equals DNS_resolver. These IPs, like 10.0.0.35 in our example, are what you'll configure on your on-premises DNS servers as conditional forwarders for the gcp.company.internal domain. For testing, use the dig or ns lookup commands. from a GCP virtual machine. Test with digdatabase.company.com to verify it resolves via the on-premises DNS from on-premises. Test with digapi.gcp.company.internal at 10.0.0.35 to verify it resolves via cloud DNS. This bidirectional testing confirms your hybrid DNS solution is working correctly. Remember, the on-premises configuration is equally important. You'll need to set up conditional forwarding on your on-premises DNS servers pointing to the cloud DNS inbound forwarder IPs for your GCP domains. This completes the bidirectional DNS resolution circle. Let's wrap up with a summary of our DNS solution and some critical best practices for implementing hybrid DNS architectures in production environments. We've established that DNS forwarding for private zones with inbound DNS forwarding is the correct solution for bidirectional DNS resolution between GCP and on-premises networks. This approach provides security through private zones, connectivity through forwarding, and bi-directionality through inbound policies. It's the only option among the four that meets all our requirements. For best practices, always use private zones for internal resources. Public zones should only be used for genuinely public-facing services. This maintains security boundaries and prevents accidental exposure of internal services. When setting up forwarding, always specify multiple DNS servers for redundancy. If you only configure one and it goes down, you lose DNS resolution. Network connectivity is crucial. Ensure you have reliable, low-latency connectivity between GCP and on-premises, typically through Cloud VPN or Interconnect. DNS is latency-sensitive, and slow DNS resolution will impact application performance. Also, implement proper firewall rules allowing DNS traffic, which is TCP/UDP port 53, between your environments. Monitoring is often overlooked but essential. Set up cloud monitoring alerts for DNS query failures and response times. Use cloud logging to track DNS queries for troubleshooting. Many hybrid connectivity issues manifest as DNS problems, so good monitoring helps you quickly identify and resolve issues. For large organizations, consider implementing a hub-and-spoke DNS architecture where a central project handles all DNS forwarding. This simplifies management and provides a single point of control for DNS policies. Also, document your DNS architecture thoroughly. Include zone names, forwarding rules, and IP addresses. This documentation is invaluable during troubleshooting or when onboarding new team members. Common pitfalls to avoid include: don't forget to configure reverse DNS zones for IP to name resolution. Don't use overlapping IP ranges between GCP and on-premises as this can cause routing issues. And always test failover scenarios. For example, what happens if one of your on-premises DNS servers goes down? Thank you for your attendance. Please consider subscribing to the channel.